Okay. Oh, my latte looks not very nice. Disgusting. I will never drink cream on top. Okay. Right. So, bit of into the unknown for me. Done a problem like this before. So we've got a statically indeterminate problem this time. Got the wall there. UDL reaction here, like that. UDL acting downwards. So it's statically indeterminate because we are going to be forcing this back to its position, so it's in effect straight. We're expecting it to sag obviously in the middle. So we have an unknown there. So if I do my free body diagram, I'm going to get an unknown there, which is, I'll call that reaction RB. It's RBY, RB for short. It's on the runners, and then we have the reaction here, RAX, RAY, but this thing is going to be trying to be turning at that point there, so I'm going to get some kind of turning moment there. Okay, so I'll call that MA. So let's do the reactions first. Okay, so RAX, obviously that's going to be 0, so sum up forces going off in that direction there. That gives me RAX equals nothing else there, 0. Now sum up forces in the y direction. And what we got there? Well, we got RAY. Our UDL is same thing, so UDL is little w, and the length of it is actually it's the lower bit of the beam. The length of it is L, so we have RAY going up, and we got minus little WL going down, plus RB, I could call that RBY actually, RBY equals 0. Okay. Right, the moments. So at moments I have to take a cut through my body. Oh no, I'm taking moments on the external forces first of all. So the moments on the external forces take them about point A, so we get, I'm going to go clockwise, so that's at A, clockwise. That load's going downwards, so that would be a total weight of little w times L. Its centre of mass is half L. So that's going to create a moment there. This one here, opposite direction, so minus RBY times L equals 0. Okie dokie. So could tidy that up, I suppose, before I move on. So MA minus RBY times L plus little w L squared over 2 equals 0. That's equation 2. And here we're going to get equation 1. RAY plus RBY equals little w times L. That's my equation 1. Rightio. So the next thing is to now to take a cut for the body and then expose. Well, we're really looking for M, so looking for an M, going for the body. So take a cut for the body. So we also got a shear there, but not bothered about that, I think. X is 0, not really bothered about that either. MA, he's going around that side. So I've got M equals, so what we got here, that will be, this is some arbitrary distance x. So we've got RAY times x. Obviously RAX goes through the pivot, so it doesn't create any turning moment. And we are adding up clockwise moments, so that's plus MA. MA I've found to be this. How am I going to use that? Maybe. The thing I've forgotten, of course, is the UDL itself. So the UDL, that's going this way. We have gone for clockwise, so that's minus. What's the length of the UDL that we're looking at? So this particular section we're looking at X amount of UDL, so little w times by x is the weight. What's the distance from here to here? Well, it's half of x, so that's going to be x over 2. So let's tidy this up. So we've got m equals minus little w x squared over 2 plus RAY x plus the MA term. So I could use that. Don't think it really helps me. It's just a constant. Right. So we've got an M equation. Let's stick it in EI delta squared y over delta x squared. So I'm going to stick it into this equation, brought the EI over to the left hand side. That's minus little w over 2 x squared plus RAY x plus MA. Okay, so at the moment, unknown, unknown, unknown. So my think my problem is actually going to fall out nicely because it's an indeterminate problem, but I think that'll be fine. So, got that. What's the first thing we're going to do? We're going to integrate that again. EI, so it becomes a first order differential on the left hand side. Integrate this, minus little w x to the power 3 over 6 plus RAY x squared over 2 plus MAX. Integrate that again. EI, that becomes a function of x, so that becomes minus little w x to the power 4 over 24 RAY x to the power 3 over 6 MAX squared over 2 plus, must be my first constant, which means I'm in a mistake. I forgot my constant there, so plus C1, so that's C1x and C2. Forgetting my constants. Right, so there we go. What do you want me to do next? Go back to the problem and start applying boundary conditions, please. Okay, so first obvious boundary conditions we got is that y equals 0 when x equals 0, y equals 0 when x equals L. They're the first obvious boundary conditions to apply. So x equals 0, y equals 0 equals this. So that goes, that goes, that goes, that goes. C2 equals 0. Easy. Right, next boundary condition is, I guess, y equals 0 when x equals L. What do we get? So x equals L, y equals 0. What does that give me? Minus little w L to the power 4 over 24 plus RAY L to the power 3 over 6 plus MAL squared over 2 plus C1 times L. A mess, so I'm doing something wrong. Right, so that boundary condition was easy. This one we will bag for now and see if there's any other boundary conditions. What about a gradient? Yeah. So if we imagine this thing here, it's attached to the wall, so the gradient is going to go off 0 here. So that will get rid of my C1 nicely. So we will scrap this and we'll do boundary condition 2. We're going to use this thing here instead. So delta y over delta x when x equals 0. So 0, 0, 0, C1 equals 0. Okay, that was found easy enough. Right, so apply the boundary condition that x equals 0 there, the gradient equals 0 there. What am I going to do next? Third boundary condition I need to have is, let's use this boundary condition that I scrubbed out. Although C1 equals 0, and I now know that. So that gives me boundary condition 3, which is when x equals L, y needs to equal 0. Therefore 0 equals minus little w L to the power 4 over 24 plus R A Y L to the power 3 over 6 plus M A L squared over 2. Looks like a C. L. Do we go back to the beginning? So we've got this equation. Substitute this into this, and then use this to find RA and RB. It's a plan, isn't it? So therefore we've got anything cancelling at the moment. I can multiply through by 24. I've got too many L's squared, so let's do that. So I'm going to multiply this by 24 and divide by L squared. So that gives me 12 MA plus 4 R A Y times L, take away little w L squared. Okay, I think I've got that right. Equals 0. Go back to equation 2 here. So that becomes therefore 12. This over to that right hand side gives me RBY times L, take away little w L squared over 2 plus 4 RAY times L, take away little w L squared equals 0. Right, multiply this out. So we've got 12 RBY times L, take away 6 little w L squared plus 4 RAY L, take away little w L squared equals 0. Doesn't look particularly good. And then up with a minus 7. And we've got excess of L's now, so let's divide through by L and tidy. RBY plus 4RAY minus, I don't like 7. Why is 7 coming from 7? Little w, L equals 0. Right, so go back to this guy, substitute him in. What should we do there? Times this by we'll times this by 4 and then take away this. So that therefore gives me 8 RBY. So I've taken away 4 RBYs. Take away 4 RAYs equals 0. Right, that this thing needs to go onto the left hand side, so it's minus. So it's times by 4. So I've got a minus, take away gives me a plus. So plus, or rather minus 7 plus 4 equals minus 3. Little WL equals 0. So therefore RBY equals 3 little WL over 8. Go back to equation 1. RAY equals big little w times L, take away 3/8 of it, equals 5/8 little WL. Okay, dokie. Now let's find an equation to find the MA. What's the easiest one to use here? Could go there. Anything easier? This thing here, I think. No, I think equation 2 looks easier. So we have MA equals RBY, so that's that. 3/8 L little w L squared, when it goes into that side. Take away little w L squared a half. So 3/8 take away 4/8. That's right, isn't it? Equals minus 1/8 little w L squared. I don't know if you've worked the work solution in the book, they took MA to be anti-clockwise. Don't really know why. My tendency would be to take it to be a clockwise at that point. So in the book it's a positive, but that's not a problem. Determine the reactions. Actually, we didn't need it. Determine the reactions of the support. So there we go. So the reaction is R. So we've got 5/5 at A. 5/8 at A, and 3/8 at B. 3/8 at B, Yeah, I suppose so. Okay, so job done.